Hello and welcome to this lecture of fourth normal form. In the previous lectures, we talked about first, second, and third normal form and also BCNF. So what is fourth normal form? Fourth normal form aims to address and eliminate the multi-value dependency. A multi-value dependency is a type of dependency that occurs when there's a relationship between attributes such that for every value of one attribute, there are two values of the other attributes that can be derived in other columns. A multi-value dependency represents a dependency between non-key attributes that have multiple values. So there should be at least 3 columns in the table, and also it can exist for more than one column, like A drives C. To understand the multi-value dependency, consider a table name table 1 with the following attributes: A, B, C, and D, where A is the primary key. Here we have a multi-value dependency between attribute sets BC and BD. For every combination of B values, we have a set of associated C values that is independent associated set of D values. In other words, if we have two rows in table, that is row 1, A1, B1, C1, D1, and row 2, A2, B1, C2, D2, we can observe that the values of C, C1, and C2 are associated with B1, while the values of D, D1, and D2 are also associated with B1. This demonstrates a multi-value dependency between the sets of attributes BC and BD. To normalize this table containing multi-value dependencies, we typically split the table into multiple tables. In this case, we would create two new tables. That is table A or table 2 and table 3. So in table 2, A is foreign key referencing table 1's primary key, right? And table 3 has a foreign key A, which is referencing table's primary key. By splitting the original table into separate tables, we remove the multi-value dependency. Now each new table represents a single entity, and the relationships between entities are maintained through the foreign key. Now let us consider a scenario of real-world example. In this scenario, we have a table in the third normal form, and we can further break it down into fourth normal form. In the original table, there are no transitive dependencies. The table represents orders with order-specific information and the associated customer, product name, and category. To further normalize this table into fourth normal form, we need to identify the non-trivial multi-value dependencies. And in this case, we can observe the multi-value dependency between the product attributes, product ID, and category. To achieve fourth normal form, we can break down the original table into separate tables. In the revised tables here, you can see table 1 represents order-specific information only, including order ID, customer ID, and product ID. And table 2 represents the relationship between products and categories, where each unique product is associated with a specific category and it has a specific name. By splitting the original table into separate tables, we have eliminated the multi-value dependencies between product ID and category. And we can say that the fourth normal form has been achieved. This normalized structure allows us to better query the data, organize it better, eliminate the redundancy even further, and provide efficient querying and management of orders, customers, products, and categories in a database. Please note that all the real-world scenarios might not require fourth normal form, and it depends solely upon the design of the tables that we intend to achieve. I hope we are clear with the fourth normal form in this lecture, and in the next lecture, we'll be talking about fifth normal form. Thank you and see you in the next lecture.